some key terminology for this particular part, I suppose, is looking at that example we just looked at on the board, 794 divided by 6. There are 4 main parts to this long division algorithm that you need to know what the, I suppose, technical term for it is, because it gets referred to quite a bit throughout this particular topic. But you have a dividend, which is the number that's being divided. You have a divisor, which is the number that is doing the division here. You have a quotient, which is the result, and then you have the remainder. Okay, so we're going to be referring to those terms in terms of polynomials. So if you have the dividend polynomial, the quotient polynomial, the remainder polynomial, the divisor polynomial, okay, you will need to know what those particular things do or why they are called what they are. All right, so I suppose just making sure that you're aware which parts relate to what there. What we've got here, applying this process to long division of polynomials. So the same process can be used to divide polynomial functions by another polynomial function. The leading term in the divisor is divided by each term in the dividend until a constant term remains. When we divide the divisor polynomial, p of x, or the dividend polynomial, so a given polynomial, the dividend, by d of x, the divisor, we obtain 2 polynomials. One is the quotient, the solution, the other is the remainder. Okay, so the quotient polynomial q of x, the remainder polynomial r of x, such that you get this particular result. Okay, where if we look at putting this in terms of the number problem that we just did, 794 divided by 6 was our problem. Our solution to that was 132 remainder 2. And so what we've got here is 132 as the quotient plus 2 over 6. Okay, so you're taking your dividend and dividing it by something. The result gives you the quotient plus the remainder divided by the divisor. Okay, that's kind of the way you're looking at this particular notation. The other thing that you can take from this then, that can be transposed and rearranged so that you get this polynomial function being equal to the quotient multiplied by the divisor plus the remainder. So looking at that in terms of what we just calculated with numbers, 794 here is going to be equal to 132 times 6 plus 2. Okay, and if you work that 132 times 6 out, it gives you 792. Adding on 2 gives you your 794. So this particular result, I suppose, is just something when you're looking at these solutions that you get. The original polynomial that you start with should be equal to your quotient multiplied by your divisor plus the remainder. Okay. From there, I suppose in this example, r of x can be equal to 0, or r of x has a degree that's less than d of x. So when we were talking about degree last time, your remainder has to have a degree less than your divisor. Looking at an example of this, well, there are a few examples that we're going to look at doing. We're dividing x squared plus 7x plus 11 by x minus 2. So whenever you guys are looking at doing this, you're going to look at using a linear factor to do it. And so setting this up using your division algorithm, x minus 2 is dividing x squared plus 7x plus 11. What that note on the last page said that the leading term in our divisor divides all of the terms in our dividend. And so what we're looking at here, until just a constant term remains. So x is going to be, or x squared is going to be divided by x. And if you think about x squared divided by x, the solution is just x. What I like to see that you do in this, just to keep things all well organised as far as your polynomial goes, is that when you divide x squared by x and you get the result of x, we put that over the corresponding, I suppose, place value of that polynomial. All right, so rather than putting x over the top here, putting it in terms of where the x column is in your polynomial there. So what, I suppose, the thinking that we had there, x squared divided by x gives us x. That was step one. What happens now in terms of your long division? So we've taken x squared, we've divided it by x, the result is x. Now we're coming back, x times x gives us x squared, and x times minus 2 gives us minus 2. So you're taking that x that you have as the result of your first division, you're multiplying it by both terms in this linear factor. Okay, so x times x is x squared, x times minus 2 is minus 2x. And per our long division process, we're looking at taking this away from what is above it. Okay, so here now that negative will apply to this x squared, it will become minus x squared. So our 2x squareds will cancel out. The minus will apply to our negative 2x here, turn it into a positive 2x. And so we'll actually end up adding these two things. But minus 2x plus 7x gives us 9x. And then you're looking at carrying down your plus 11. Now what we look at doing, same thing happens again here. Our leading term divides the next term in our polynomial. So x divided by, no, 9x divided by x gives us plus 9. Putting that up into our constant column. Plus 9 times x gives us 9x. Plus 9 times minus 2 gives us minus 18. And we're taking that particular factor away. Minus 9x cancels the 9x out. Minus 18 is a plus, so this becomes plus 18, which gives us 29. And we're at the end of this particular division now. What you've got here, your quotient for this particular division is x plus 9. Your remainder is 29. And so there are, I suppose, a couple of ways we can write that based on our stuff from here. We can write it in this particular form, where you have the original polynomial divided by your divisor equal to the quotient plus the remainder over the divisor. So that would look like this. X squared plus 7x plus 11 divided by x minus 2 is equal to x plus 9 plus 29 over x minus 2. Or we could say that x squared plus 7x plus 11 is equal to x plus 9 times x minus 2 plus 29. Okay, and if you expand out x plus 9 multiplied by x minus 2 and then add 29, you will get this original polynomial. Okay, so you've found or you've got a linear factor there that you can multiply to help you produce that particular quadratic. It's not actually, it's not technically speaking a factor because you have this remainder, and we're going to cover that a little bit later in the lesson. But being able to get to the end point here where you can multiply these two brackets together, add on your remainder, and produce this particular thing that you've divided by, that's your check method, I suppose, to check that you've done things correctly. Being able to expand that back out and collect all of your terms to get your original quadratic. The other thing, I suppose, with this, we've just done polynomial division for a quadratic. Most of the time for quadratics, you can factorize them. If they have factors that are going to generate x-intercepts, you can just factorize them. This process is actually more, like we're actually learning this particular process so that you can apply it to cubics. So there are a couple of examples coming up now where we're going to do some work with a cubic. But setting up your division algorithm is always your first port of call here. So x plus 2 is our linear factor that we are looking at dividing by, and our cubic polynomial, 3x squared minus 3x cubed minus 4x squared plus 2x plus 1 is what we're going to divide. Leading term of x is dividing 3x cubed will give you positive 3x squared. So you're cancelling out one of the x's here. Next part of this process, you're taking your 3x squared, multiplying it by both of these terms. So 3x squared multiplied by x gives us 3x cubed. 3x squared multiplied by plus 2 gives us plus 6x squared. And we're taking that away from the top line. So in here now, negative 3x squared, negative 3x cubed cancels out your 3x cubed. Negative 6x squared makes this negative 10x squared. And we're bringing down your plus 2x. Minus 10x squared divided by x gives us negative 10x. We're now coming back, negative 10x multiplied by x gives us negative 10x squared. Negative 10x multiplied by positive 2 gives us negative 20x. And we're taking that away. So in both of these cases in this bracket here now, you're going to end up with a positive solution. So 10x squared cancels out negative 10x squared, and positive 20x plus 2x gives us positive 22x. We don't need the positive sign. And then we're bringing down the plus 1. So 22x plus 1. Last part of this cubic now, all you can pretty much see that's happening here is it just takes you a little bit longer. There's an extra step or two involved because you have a bigger polynomial that you're trying to divide. But x divided by 20, or 22x divided by x gives us positive 22. Positive 22 times x, 22x. 22 times 2 plus 44. All of that's going to be subtracted from what's above it. And so we get here that the remainder is negative 43. Quotient in this case will be 3x squared minus 10x plus 22. Remainder is minus 43. Writing this in terms of your polynomial now. 3x cubed minus 4x squared plus 2x plus 1 equals 3x squared minus 10x plus 22 multiplied by, actually we'll write that just a little bit further up so that you can see it. So 3x cubed minus 4x squared plus 2x plus 1 is equal to 3x squared minus 10x plus 22 times x plus 2 minus 43. So expanding those two brackets out, taking 43 from your result, will produce that original cubic that you started with. Okay. There's one more that we're going to do here now. If you look at both of these examples here, what can you see that's a little bit different about polynomial 1 and polynomial 2? Or the example in polynomial 3, the example in polynomial 4. Yeah, so the first one has 4 terms, second one has 3 terms. What term's missing? Yeah, okay, good. So the big thing that you need to know with this type of example, and the most common mistake that you see people make on SACs, generally we will probably give you one that looks like this simply because we know that it is a common mistake that you make. Because you're missing a squared term in here, you can actually write this as 3x cubed plus 0x squared minus 2x minus 20. And that's what you need to put into your division algorithm, okay? You can't skip the place value of that x squared term. You need to take into account that it's there and have a 0x squared term. It's 0x squared in the original polynomial, but once you start to take stuff away, you have something that's of x squared place value, and you need to make sure you've included that because you'll actually generate an x squared term for the quotient, okay? So looking at your division algorithm for this particular problem, we've got a linear factor of x minus 2 that's being used to divide this. we've got 3x cubed plus 0x squared minus 2x minus 20 as our polynomial. Dividing through here, x divided by 3x cubed gives us 3x squared. 3x squared multiplied by x minus 2 gives us 3x cubed minus 6x squared. And that's being taken away. You'll see when I'm writing these out as well, it's something I haven't mentioned yet, but what I'm doing is I'm actually multiplying through here and putting what the 3x squared multiplied by the x minus 2 gives. It's much easier to keep this in terms of that and keep your negative there, then put this in brackets and put your negative on the outside. Okay, it helps to make sure that you have definitely multiplied things right to begin with. Then you're subtracting this. You just need to remember that this negative applies to both of these terms. So if you've got a positive term in there, it's going to become negative. If you've got a negative term, it becomes positive. All right, so just make sure that that's, I suppose, something that you are aware of. It's much easier, and I find people make less mistakes if they do set it out like this and they think about it in this way. All right, so what's happening now? Negative 3x squared cancels out 3x cubed, sorry, negative 3x cubed cancels out 3x cubed. Positive 6x squared plus 0x squared gives us positive 6x squared. And we're bringing down our minus 2x. X divided by, or 6x squared divided by x gives us plus 6x. Multiplying that back through, we get 6x squared minus 12x. We're taking that away. And we get that this is equal to, this becomes positive 12x, so we get 10x. And we're bringing down our negative 20. X divided by 10x gives us positive 10. Positive 10 multiplied by x minus 2 gives us 10x minus 20. Taking 10x minus 20 away from 10x minus 20 will produce a result for the remainder of 0. So in this case, quotient is 3x squared plus 6x plus 10. Remainder is 0. And so in this case, what we can then therefore say is that 3x cubed minus 2x squared minus 20 is equal to our quotient, 3x squared plus 6x plus 10, multiplied by x minus 2, and there's no remainder. Okay, so you just need these two factors inside a bracket. The fact that there's no remainder brings us to the next point that we're going to talk about here. And what we're looking at is that we are considering where we looked, or if we consider a number example of this first. So 72 divided by 6 and 72 divided by 7. If you calculate 72 divided by 6, you get 12 with no remainder. If you calculate 72 divided by 7, you get 10, remainder 2. As 76 divided by 12 is equal to 12 and produces no remainder, it can be said that 6 is a factor of 72. So if you're thinking about factors of 72, it's all the things that you can multiply together to get there. 6 times 12, 18 times 4, 36 times 2. You can continue to list all of those off. But it's things, I suppose, that you can multiply together and it produces no remainder. Okay, when you multiply them and you get, I suppose, that number. Looking at 72, if we divide that by 7, it's something that we can do. We can divide 72 by 7, it goes in 10 times, but it produces this remainder of 2. Okay, so what then happens, you can't multiply 7 by any whole number to give you 72. So therefore 7 is not going to be a factor of 72, and neither is 10. All right, so the result that we're looking at there, to summarize that, when dividing a dividend by a divisor, if no remainder is produced, then both the divisor and the quotient are factors of the dividend. So that result that you get, 72 divided by 6 gives you 12 as the quotient. The divisor of 6 and the quotient of 12 are both factors of that dividend 72. Okay. That property is something that also holds true for polynomial division. So when you divide through by a linear factor and you get a remainder of 0, what you're finding is that that linear factor is a factor of that polynomial. Okay, it's something you can multiply by other factors and you produce the polynomial with no remainder. It's going to be really important when you get to factorization that you can differentiate between those two things. When you divide by something and produce a remainder, it's not going to be a factor. You can't use it to factorize your polynomial. When you divide it and you do get 0, you will be able to use it as a factor to factorize your polynomial. So the one that we've just done there, because we get 0 as a remainder and you have just these two brackets, what you can say about this, x minus 2 is a linear factor, 3x squared plus 6x plus 10 is a quadratic factor. Okay, so you can now go back to some of the work we've done on quadratics and you can try and factorize this particular quadratic. If it factorizes into more linear factors, then you've got more than one linear factor for that polynomial. It's going to be something we're going to look at covering in a little bit more depth next lesson. But just, I suppose, so that you're aware that that's what happens. So looking at those two examples that we just covered in example 3 and example 4, if you get asked a question like this, is x plus 2 a factor of p of x? What you would do now is you would go and you would do that division, okay? And if you do that division, you find that there is a remainder or there's not a remainder, you can say whether x plus 2 is a factor or not. Because we've already done that particular calculation, okay, we took 3x cubed minus 4x squared plus 2x plus 1, divided it by x plus 2, and we got that the quotient was 3x squared minus 10x plus 22, remainder is 43. So what we can say here is that 3x cubed, minus 4x squared plus 2x plus 1 divided by x plus 2 is equal to our quotient, 3x squared minus 10x plus 22. And we have a remainder of minus 43. So minus 43 over that remainder x plus 2, over that factor, sorry. What we can say here now, remainder does not equal 0. Therefore, x plus 2 is not a factor of p of x. Okay, so because we have this remainder portion to our polynomial, when we divide by x plus 2 is not a factor of p of x. Conversely, the other example that we looked at divided 3x squared minus 2x minus 20 by x minus 2, and it produced a quotient of 3x squared plus 6x plus 10 and a remainder of 0. So what we can say about this, 3x cubed minus 2x minus 20 divided by x minus 2 is equal to 3x squared plus 6x plus 10 multiplied by, it's actually just equal to that. So it's equal to 3x squared plus 6x plus 10. Because there is no remainder, or remainder is equal to 0, x minus 2 is a factor of p of x. Okay. So that's pretty much everything that we're going to look at for today. You guys are going to have a chance now to be able to have a look at doing some polynomial division. Once again, there are some notes in your textbook there that summarize this. So that identity that we looked at, p of x equals d of x times q of x plus r of x. And I suppose just some summary of the terms, the quotient, the remainder, and what those polynomials are is there for you to have a bit of a look at. Big thing that you need to be able to make sure that you get your head around is that you know how to do the long division algorithm using numbers. Okay, if you're okay with that process, move on to doing polynomials. If you can't do it with numbers, come and sit with me, we'll have a look and get you to the point where you can at least do long division with numbers. Okay, because it's going to be really important you can do that first. You need to understand that process to be able to apply it to polynomials. Okay. Have a go at this. Tomorrow we move on to looking at factorising using this. So it is quite a long lesson tomorrow. So have a go at some of these tonight, just to get your head around making sure that you can divide, and we'll continue on with some work factorising tomorrow.